Towards the end of the last section where we covered just some basic modeling tools and workflows, we introduced the concept of the group. And the group is what I like to think of as the Houdini version of what the selection tag is in Cinema. So if you're not familiar with the selection tag, you probably are, but just as a quick refresher, I'm going to throw it on a sphere in Cinema here, and then I'm going to make it editable. And I'm just going to select some faces here and then go up to my select menu and say set selection. And then you can see over here on my sphere, if I select away from the sphere, I've got this little tag here that says polygon selection. And if I double click it, it restores the polygon selection that I've made over here. Likewise, I could go and select, a group of points like so and say set selection again. And we get another type of selection tag over here. This is a point selection tag. And then if I were to go down here and I have a material down in my dock, if I were to apply that material to the sphere, but I only wanted to apply it to this selection tag right here, I could just go back to my material and then assign it a selection tag. And effectively, I'm only assigning a material to this area that I had defined as a selection before. So that's really at the base of it, how groups work in Houdini. So let's just do a couple quick examples to kind of, further drive home this point and how we can dynamically and procedurally create groups on the fly in our networks. So I'm going to throw it on a grid to start off with. And I'm going to dive inside the grid. And I'm going to give it some more rows and columns. Let's make it 50 by 50 just by cranking those sliders right there. So now let's create ourselves a group. I'm just going to hit tab and type group. And we get our group here. By default, it's selecting all the primitives because we haven't sort of defined, we haven't defined any restrictions for this yet. So it's simply just going to group everything that we have. Now, what we did in the last section was we created a bounding box and we grouped points inside of our bounding box. We can do something similar by selecting our manipulator and we can drag out a group of primitives that we want to keep. Likewise, we could just change this to points from this drop-down menu up here. You see that switches to these little orange dots to signify that those are the points in our group. Instead of a bounding box, we could use a bounding sphere, and then our selection changes into kind of a circle shape, like so. So, if I wanted to then say perform a function only on these points, for example, we'll just delete them. I'll throw it on a delete node. And I'll wire this in. And this delete node by default is going to be deleting nothing. But if I go and select group 1 and choose point mode, because it's expecting an incoming point group that we created here, just to be consistent, I'm going to name this delete me, or the delete group. And then down here, it has broken that group reference because it's expecting group 1, which this was initially named in the group name field. I'm just going to go back here and call this delete as well. So now that's all linked up. And then if I go back up here and grab my manipulator and move this around, I'm just deleting little areas based off of the point. So other things I could do is I could actually, wire in actual geo here. If you look under this keep in bounding regions section, I could put in a bounding object. So if I throw down my pig head test geometry, and I'll just wire this into the second input and put a little transform below it. Just so I can have a nice handle that I can move the pig head around with. But you'll see here it hasn't updated yet. It's still on bounding sphere. I'm just going to change this to bounding object. You can see that wherever the profile of the pig is now, if I move this around, you can see it. If I increase the scale, wherever the pig head is, it's deleting those points. Now, an interesting concept is the idea that in our groups, we can only use a bounding object on points or vertices. If I switch this group back to a primitive group, it throws an error here saying the bounding option only works with point groups. So one way I can get around this is I could, just go back to point groups, the way it's selecting, the way it's expecting our bounding object to work here. And then I could use a group promote. Group promote is basically what, like, changing your selection type. So if I have on my group promote here, I just select the group that I want to change, and I'll just select the delete group. And by default, it's changing the delete group from auto to points. So auto means that it's detecting that there's a point group in there, and then it's changing it to points. But we want primitives, so I'll just select primitives. And then down here on the delete node, since the delete node is still expecting points here, I just got to change that to primitives. And now our pighead is knocking out a nice kind of it's got, these we don't have intermediate polys where there aren't points now. It's kind of been squared off, so I can translate my pig around, and it is sort of taking these pixelated chunks out. So that's cool. I'm just gonna do one more thing and show how we can actually combine groups in sort of Boolean like ways. So I'm going to create another group. And I'm going to call this group the exact same group as the delete group. I'm going to call this group the delete group up here. And these are both set to primitives. Or no, this one, the first one's set to points, and the second one is set to primitives. I'm going to set the second one to points as well. And you can see that everything goes away because we have our delete flag shown. And this group now that we've created, delete, since we've given it no real instructions as to, or restrictions as to what its group is, it has selected everything. So that's because this option right here, initial merge, says replace existing. We could do union with existing. That doesn't do anything. Let's say intersect with existing, and that kind of brings us back to where we were, or subtract from existing. And that makes basically nothing happen. Let me turn on the bounding regions again, just to make this point a little bit clearer. I'm going to go to bounding sphere, and I'm just going to make this sphere a little bit bigger. And you can see here, if I go back to union with existing, now the group that it's creating is creating a group out of itself and combining it with the delete group that was incoming. Also, we could do, let's try just only intersect with existing. So really only where the pighead and this sphere overlap are we going to get any type of grouping effectively going through to our delete group. If I just, I'm going to just remove this group promote and change the deletion mode back to points just so we can see kind of the difference. Now we get sort of these angled edges, whereas before we would get these sort of squared off edges. So just a little note there about how you can use different types of grouping methods and then combine them together to kind of create these overlapping patterns and such. Next, let's try doing a different type of a thing with a group. I'm just going to go back up and highlight my grid here, and let's just throw down another group. Except this time, instead of group, I'm going to choose group by range, which is the second option here. Group by range allows you to kind of do some cool things by, I'm just going to turn off the display flag on the pig head. And I'm going to hold option here to move, to add a little knot here, and so that these aren't overlapping. So, okay, so back to this. Over here, we've got this group by range now. I'm just going to wire in the grid and select the group by range. And you can see here, this is a different type of way of selecting groups. Here, it's actually selecting primitives, which is awesome. And we could change this to select like various numbers of primitives, in a pattern. So right now it's selecting one of one, which basically means it's selecting all the primitives, one out of every primitive. If I do one out of two, we get sort of this checkerboard pattern. It's selecting only one out of every two primitives. And you can change this value to create like different ranges. So if I wanted to go to, something like this, and then I could offset it slightly, you can see you can kind of change that and move that around to get different results. So if I just keep playing around with these, you can see it's just going to kind of shift everything. And I can kind of like get to this point where I've got kind of a cool zigzag pattern. And, if you have something in mind, you can go specifically for that. I sometimes find it's fun to just experiment and, play around with these kinds of things. Let's see if we can find, let's do something like, let's do a larger number. We'll select something like that, so we get kind of like a zigzaggy like pattern. So now, like, I could throw down a poly extrude, and if I just wire this in and select my poly extrude and increase the distance, it's going to be increasing everything. But if, like most nodes, there is usually a group field at the top here. We can just select group 1, and now we're kind of extruding this interesting pattern out of our geo. And you can go back to your group, your group range selector and start messing around with these values and offsetting them and sliding them around and, finding something that, something that's cool for you, It's pretty handy, and definitely you can definitely make some cooler things than this, definitely. But yeah, you can make some cool stuff with it. So just something to keep in mind, that is another option that you can do with groups. Thirdly, let's do the group expression node. The group expression node will allow you to kind of use simple expressions to, do various things and generate your groups. So let's create another primitive group. And, if you want just a little hint, over here on the right-hand side of the expression field, there's a little drop-down menu that gives you all sorts of presets that you can choose from. So, you could say, I want an expression that chooses, primitives that are within a radius of 1 sphere from the origin. And you can see that it does that. If I were to, just option drag this poly extrude over just to illustrate the fact, you can see here that it is extruding that group that we created here. And that is because by default, this group is generating group number 1. And on here, we have specified group number 1. Now, if I wanted to be more explicit, which you probably should be, we want to say, like, this is the extrude group, because we want this group to be extruded. And then on the next step, I would say up here, I could select from the drop-down menu. It will detect what groups I can use, and it sees the extrude group, so I can just add that one. And since group 1 actually doesn't really even exist anymore, I can just delete it from this list. It's not going to affect anything. So just something to note. You can also see that if I were to hover over a node that is generating a group, or even a node below where a group has been generated, as that group is flowing through the network, if I were to click this info button, you could see I have this extrude group available to me, and there's 69 primitives in it. So a primitive group, name is extrude, and it's got 69 primitives right there in the middle. You can see all sorts of other cool information on this, but it's really great for identifying what groups you have that are available. It's good for debugging if for some reason your group is empty and you weren't expecting it to be. You can find out all sorts of stuff about that in this little info panel. I got to that by hitting this I key. You can also get to that by just middle mouse clicking directly onto whatever node you want to explore. You can see over here we've got a group 1 with 368 primitives in it. That's what was generated by this pattern that we created. So that's a cool example about how, like, the group by expression works. We could try one of these other examples. Let's see, we've got let's try 30% chance. This will give us sort of a random selection of primitives. And so yeah, that's generating 30% of the primitives are being selected, and then we're feeding that into our extrude, and they're being extruded upwards. What you could do is you could even take this a step further without getting too heavy into it, but suppose we wanted this to be a slider. I could just, instead of hard coding 0.3 in here as the preset has done, I could just write out CH, which is a channel reference like we were doing when we were doing relative referencing earlier. Open quote, and then I could just name this whatever I want. I'll just call this my underscore slider, end quote, and close parentheses. And so you can see it doesn't know what to do now because this slider doesn't exist, but this handy little button over here will create spare parameters based off of whatever call we made. And because this is a special language that is referring to a parameter that doesn't exist yet, and this parameter button recognizes that that is what's occurring right now, when I click that, it creates a slider for me. And now when I slide my slider, I can, change dynamically from 30% to 58%. So basically it's just assigning a random seed based off of whichever primitive it's on. And then if that random number is less than this value, add it to the group. So that's one cool way that you can kind of create groups out of random primitives. Another thing I want to talk about is how we can bring data together in streams and then split it back apart. So let's say we've got I'm going to throw it on a box, and I'm going to throw it on a sphere, and let's just merge them together. For my sphere, I actually am going to go with not a primitive, but a polygon. And I'm just going to increase the frequency to, say, 10. That's good. I'm going to move it off to the side here, and then I've got my box. I'm going to just, actually, let's merge these back together. I'm going to select my sphere. I'm just going to make it a little bit smaller and then bring it in like so, and maybe like this. So it's just kind of touching the corner here. And then with my box, instead of doing just a straight polygon, I'm going to do a polygon mesh, and then I'm going to increase its axis divisions to something like 20. That looks good. So now we've got our box and our sphere merged together. Now, if I were to middle mouse click here, you can see that all I've got is just a bunch of points, primitives, and polygons. And there's no real way of me knowing once this merge has happened which parts are part of the sphere and which parts are part of the cube. So I could just create two groups like I did before. So let's put down a group for our box. And I'm just going to drop that on that wire right there. And I'm just going to name this our box. And you can see that it has... if I go and set the flag here, that it is selecting all of our box. I'm just going to option drag that over here, and I'm going to rename this one sphere. So you can see now down here on our merge, where we've merged the box and sphere together with groups assigned to them, we have two primitive groups, our box with 2,166 primitives and our sphere with 2,000 primitives. So now if I did some operation on them and wanted to split them back apart, I would have groups in which I could do that. And I could throw down, for example, a split here. In the split field, if I choose one of the groups, by default, it's just going to send the other group out the other side. So if I throw down two nulls, I'll call this my box null. As depicted, it's showing whatever this first output is. And we can't see the second output, but if I just wire in a node here and then set the flag there, you can see that we have made our box and our sphere. We've effectively put them together and merged them into one piece of geometry and then split them back apart into two separate streams. This will come in handy down the road when we start doing more complicated setups, but it's important to note that we can pass data through a merge like this and then give that merge the instructions we need to be able to, or give the split the instructions we need to be able to determine which of the two it's actually dealing with. So that might seem kind of pointless at this moment, but if we were to say add some more operations right here, you can see how it comes handy to actually be able to start grouping your geometry and then performing some stuff on it and then ungrouping it later on. So let's just, instead of a split here, or instead of a merge, I'm just going to drag these off to the side, and I'm going to throw down a Boolean. And let's union these two together. So here we've got our Boolean node. I've wired the box into the left and the sphere into the right. And by default, whoops, I accidentally disconnected that. I'm just going to wire that back up. By default, it's creating the intersection between the two. I don't want an intersection. Let's do a union. So here now, if I go inside, you can see that it's actually, the sphere and the cube are actually now one solid object. If I switch to wireframe mode, you can see that they're no longer, they've kind of cut into one another and are one hull at this point. And so now what I could do is I could throw down a divide. So I'm just going to divide everything here. I'm going to hit W to go back to regular mode. So you can see the effect of the divide is basically just triangulating all these polys on the on the cube. And then, like, say I wanted to add a noise, so I'll do a mountain. Now the mountain, if I add the mountain here, you can see that it's adding noise to everything, but suppose for whatever reason I wanted to only add noise to my sphere. Well, I could bring the mountain up here and just apply it to my sphere, but that would, that's not always, an option. Sometimes you really want to have, you want to determine where in the flow of your project you're actually applying certain operations. So we could do that by going to our mountain and selecting that we only want to be applying the mountain to our sphere. And you can see that for what it's done now is it's actually applying the mountain to nothing. The noise pattern is not affecting the sphere. And I think that that's because the mountain is actually expecting a point group, not a primitive group, which we set up here when we said we wanted our sphere to be a primitive group. So I'm just going to apply a quick group promote, and we're just going to change the sphere group to points. So it's auto detecting that sphere is a primitive group, and it's changing it to points, a point group. And now the mountain is seeing that sphere group and only applying that noise pattern to the sphere. Great. So now, like, I could throw down a smooth, for example, to try and kind of unjaggedify. That's not even a word, but you know what I mean. Reduce the jagginess of this, and then yeah, like if I, you can see I've got kind of this interesting kind of blobby thing happening here, and I could actually go back up to my sphere. And this is the fun thing about the proceduralism, is that now all this is live. I can grab the sphere, I can resize it, I can reposition it, and it's going to be moving through that noise field and attaching and detaching itself from this setup. I'm just gonna kind of crank down the filter quality, maybe crank up the strength a little bit, just so we can get something a little bit softer. And you can kind of see, if you were to go up here and just animate the translation of this sphere, you could get some kind of interesting kind of globby stuff. And we haven't even done any volume modeling yet. This is just straight up Booleans and smoothing, and it gets these kind of cool results like that. So, suppose you got here and you said, like, oh, this is great. Like, I really like the way that this is working, and I just want to make, the sphere to be red or whatever. At this point, you could, throw down a color and just, apply the red color to everything, or you could just select you want your sphere to be red only. You've added, a color to, only the sphere section. And then, after all of this is said and done, we could just go back and split the stuff back off. So if I, middle mouse click here, you can see I've got a primitive group as a box, a point group as a sphere. And that's because we promoted our sphere group to points. Well, if I just option drag this group promote out and then switch it back to primitives and wire it into the bottom here, you can see that now we've got two primitive groups, our box and our sphere. It's just promoted the sphere group back to primitive group. And then if I just go down here and wire back in my split, you can see that we've split off the box and we've split off the sphere. So if we wanted to work on these two geos separately, we now have that option still available to us by just managing our groups through this relatively simple network. Awesome. So another thing, just another example I wanted to explore is that groups can be created dynamically by certain nodes. So for example, if we had let's just throw it on another grid. And I'll just frame this up by hitting spacebar F. I got a template flag down here on my box I'm going to remove. I'm going to go back over here to my grid. So let's just select, I'll just make a group selection manually here by using like my lasso tool. So we'll do that, and then I'm just going to, hit group. So that's created our group for us, and dynamically, because I'd selected over here in the viewport, it adds that group field in here for me manually. And I'll just call this my extrude group. And down here, if I throw it on a poly extrude, and I will select my extrude group that I created up here from that drop-down menu right there. Then I just give it a little bit of a distance. Let's just increase that up to like, 4.5, something like that. That's cool. I'll add some divisions to it. I wonder what a twist will do. Yeah, let's do some divisions and a twist just to add, just because why not? So, we've done this extrusion, and then suppose like, we wanted to scatter some, spheres on the side of, just only on the sides, not on the ground and not on the ceiling. So if I throw it on a scatter now, by default, it's going to scatter points all over the entire geo. You can see that it's scattering points on the roof, on the floor, and on the walls. If I were to go, back up to this poly extrude, if you scroll down a little bit, you can see that the extrusion's you've got some other options. You've got, you can create a front group, which is this node will automatically detect what the front group is and create a group for it. Or you could create a back group if you actually enabled your back. That would close this bottom part off, or you could choose something like your side group. I'm going to turn the side group on, and you can see here it's by default says extrude side. I could change this if I wanted to be something else, as long as I just use whatever I type here in whatever node I want to be accessing that group, it'll totally match up. So in scattered here, if I go up to my group selection and hit this drop down, you can see that, well, I've got my extrude group, which I created up here. Now it has extrude side. So let's select that. You can see that it is only scattering points on the sides of our geometry. So now I could do a copy to points, and I could throw it on a sphere. I'm just going to make the sphere a little bit smaller. I'm going to change the number of scatters. I don't want to scatter 1,000. Let's just scatter something like 50. And I'm going to turn off relaxation just so that's a little bit more random. And I'm going to wire the sphere into the left and the copy to points in on the right, or the scatter into the right. And then I'll set my display flag there. And then if I just throw down a merge, I'm going to bring out, just going to delete that one over there. Just bring this whole group off to the side a little bit more. If I just were to click on this grid, I'm just going to hold down Option and click right here to create a little knot, and then I'm going to wire that into our merge, and then I'm going to click on this top bar of the merge again and wire it to the bottom of copy to points, and you can see, oh, I selected the wrong part of my network. I didn't want to select the grid. I actually wanted to select this poly extrude, so I'm just going to wire the poly extrude into that knot instead, and you can see now I am only scattering points on the side of that extrusion that I wanted to do. So I can, crank up my spheres, and they're going to stick to that, that selection group that we made. Sweet. Another cool group that is made by nodes is like by the Boolean SOP. So let's do a fun little example of how we could do something like create a procedural weld. So I'm going to create a tube. And I'm just going to highlight the tube. I'm going to switch it to polygon mode so that we have a mesh here. I'm going to, let's make the height something like 10, and then I'll put, 50 columns around the outsides. Then I'm just going to click this button to add end caps. Sweet. Now, you can see that my manipulator handle here, it looks like it's set to scale mode. If I just right click on that, you can see you can cycle, translate, rotate, scale. I'm just going to right click. I could do this using Y, but that's just to get back to my normal manipulator mode, like so. So I've got my tube here. Now let's intersect this tube with itself. So I'm just going to hit a transform over here in my network view and hit enter. Oops, that's a soft transform. Don't want that. I just want a regular transform. There we go. I'm going to throw that down and wire it in. And I'm going to set my template flag to the tube and my display flag to the transform. That template flag is, again, that second flag in, that pink one. So I can get sort of a wireframe reference of what my other tube looks like while I move this tube. So let's grab this guy. I'm going to rotate it. I'm going to hold down Control just to give it a perfect, that helps it snap to 45-degree angles. And I'm just going to drag it over here, and we'll just put it like that. So now, what if we want to is there a group that we can use to detect this intersection? I'm going to just scale this down a little bit and bring it back in so that they're both intersecting. So let's throw it on a Boolean. And I'm going to wire the original tube into the first and the second tube into the second. You can see that by default, it's doing that intersection again. What I'm going to do is I'm going to choose the, let's just choose detect or seam. So by selecting the seam group, by selecting the seam operation in the Boolean, you can see that it has created sort of this, it is detected where these two objects have intersected with one another and defined that seam for us. Now, there are a bunch of other groups that are created by the Boolean. If I were to put down, if I were to put the option to detect, and then it's crazy that this node has changed since I wrote my lesson. So I'm gonna just previously the way that this node worked for me was I threw down my detect, and I would get different groups such as seams. So for example, if I did a union here, it would give me it would fuse these two tubes together and then give me my different groups. For example, parts of A that are inside B, or edge groups such as A, B seams, which is where these two sort of intersect. Now, if I go and I throw down a blast node, a blast node is a great way to delete things if you need to isolate a certain group. So I could, from here, wire in my Boolean and use blast, which is by default going to delete everything. But if I choose the group that I don't want to delete, and then say delete non-selected, that group will appear for me right here. Now, in my previous version of this example, I did some fancy stuff to get this to behave as one consistent piece of geometry all the way around. I was doing things like resampling and fusing, which I can show you right here. The first thing I'll do is I'll throw down an ends, and an ends is going to just sort of allow me to unroll. See how this goes from having some of these, if I say no change, you can see how there's like this polygon here, which is really kind of, these polygons are sort of an error. I could change those and say unroll, and that sort of turns this into open curves. Now, if I turn on my points display, it's kind of hard to see, but you can see I've got some points here. I'm just going to hit the D key, and I'm going to, let's increase the point marker size just to make it a little bit more obvious. So those blue dots are really what the resolution of our points are. So I'm going to then resample these curves. So if I throw down a resample, I can get these to have many, many more points than they had originally by just changing the maximum segment length to be something like 0.01. You can see it's just made tons and tons of little points there out of it. And then what I could do is I could use a fuse. So if I hit tab and type fuse, fuse is going to look for points that are nearby each other and fuse them together. So if I start increasing my snap distance, you can see that these all start kind of snapping together into like a nice, kind of coherent loop. One thing I'm going to do up here in my resample, just to see if it makes things a little bit smoother, is instead of treat polygons as straight edges, I'm going to treat them as subdivision curves, just to give it a little bit more curvature. So if I change that back to straight edges, you can see how there's sort of these angular steps here. And if I go subdivision curves, it becomes more angular like so. Go back to my fuse. You can see that it has created this nice tubular, or this nice circular shape. I've got sort of a little jaggy here, but I'm just going to go with it for right now, just to finish this section of the demonstration. So now if I throw down a polywire, I can effectively use this loop as my weld. So you can see here, I'm getting this issue where I've got my fuse is not fully closed. If you're having an issue like that, I've just found that like the way that I'm going to solve this right now with this new fuse node is I'm going to just tweak this this snapping distance just a little bit to see if I can get that to clear up. So something like that, something a little bit smaller seems good. So we'll just go with something like this for right now. So now if I wire my polywire, you can see that it is that it goes around all the way around, and I'm going to just decrease the joint scale to 1. That basically makes it so that we don't get these large spikes that stick out. I'm going to change the divisions to something like 10, and I'm going to just turn off point display mode now. So now if I were to merge my original tube with the transformed tube, like so, and I'll also attach my weld over here. You can see I got all these sort of put together. So now if I go and move this around, provided there isn't any issue with my provided there aren't any issues with that fuse changing things on me, I can now drag this around, and you can see that it is creating my weld all the way around, no matter where I put my geo. So if I can rotate this, and it's creating this nice weld around the outside for me. Now, so right as I was starting this lesson, I learned of this new I learned of a new mode in the Boolean that I didn't know about before. But let's just try this over here real quick, just to illustrate the difference. If I throw down another Boolean, and I'm just going to grab these two, I can select both. Whoops, I'm going to hit the back key. I accidentally navigated away from my scene there, or from my grid object. So if I just select these two, grab the first one, the tube, and wire it into the first input of the Boolean, it will automatically wire the transform into the second input. So if I just drag this over here, you can see I've got tube going into the left side, and then the tube transform going into the right side. Now, if I select this Boolean, by default, it's going to be set to intersection mode. I'm going to just change this to seam mode. Now, it looks like this seam mode is a lot cleaner already than what we had to do down here with all this ends and resampling and fusing, because now I could just throw down whatever polywire we had here. I'm just going to option drag this polywire out. Now, if I just throw this in here, or even better yet, because we already defined polywire here, I could just use a simple switch. So let's go over here. I'm going to throw down a switch. The switch is a handy node for like switching between different things while you're building your network. I'm just going to drag this up a little bit so I got a little bit more real estate. I'm going to put the switch in here, and I'm going to wire the switch into the other Boolean. So we've got two things going on here. I'm going to, let's get this guy out, and just to keep things a little organized, I'm going to have this geo off to the side before it comes down into our merge. So we've got our tube and our transform one of them is going into this Boolean and then going and running this process over here. And then the other one is just going to this Boolean and doing the seam method here, where I'm not really even generating any groups at this point. This is just a better version of the example I was doing for our groups lesson. But since I discovered this, I figured why not throw it in there. So you can see that like these groups are generating much dirtier geo than just this seam. This seam is super clean. So if I go down to my switch, you can see if I select input 0, you get this solid line going into the fuse, or I get this dotted line going up to our other Boolean here. So if I grab the switch and select input 1, it switches in the dotted lines over here. Now it is actually looking at Boolean 3, and you can add a whole bunch of different stuff in here, and it will select. You can select between them. So for right now, I'm going to put it on input 1 so that it's selecting this seam group and then polywiring that, and I'll go back to the merge. And we can see here that this seam is way cleaner than what I was doing before. It looks like it's way better. If I go to this switch and toggle back and forth, you can see that it's kind of my way, the old way with the groups that I did. It's kind of having this like jagged thing happening around these edges. I'm not liking that so much. It seems that this new seam output is way better. So I'm just going to change this back to the seam mode and just give it a little test by going up to this transform and moving it around a little bit and seeing how that works. Yeah, it looks like it just cuts out nicely. If I just move this over to, say a 45-degree angle or a 90-degree angle and just bring it out here, I just want to do a little experiment with this and see how it holds up by, if I were to put in some more geometry into the Boolean. So I'm going to, let's just increase the size of this polywire a little bit. I'm just going to increase the wire radius like so. And let's do a sphere. I'm going to throw it on a sphere, and I'm going to just bring the sphere up here, and let's bring it out this way a little bit, and maybe over here. I'm going to bring the scale of it down. I'm going to switch it to polygon mesh, and I'm going to set it to the z-axis, or no, the x-axis, so that these circles are sort of facing out this way. Then I'll throw it on a mirror. And let's mirror along the z-axis. So I'm going to change the direction here over to I'm deleting 1 out of the x-axis slot and just putting 1 on the z-axis slot. So that's mirroring over here. Then I'm going to put down a merge. And I'm going to merge it with the original tube that we had here, like so. And instead of wiring this into the Boolean, I'm going to wire that into the Boolean. So now instead of just wiring the tube by itself, we've merged the tube with these spheres. And now I am sending that into the Boolean and seeing that it has detected the seams appropriately. And if I go back down here to the merge, and let's also, instead of merging in the transform, I'm going to merge in the other merge. And you can see it's created some nice eyes for us. That's awesome. I was trying to do this before with my other method, and it didn't quite work out so great. So if I go up here and start moving this eyeball around, just curious to see how the seams handle it. It's pretty good. Yeah, if I were to go back down here and hit my switch, this is the issue I was having before. If I hit my switch, you can see it doesn't really know what to do with these groups. No, it doesn't really hold up in a procedural way, quite like this new method does. So I'm hoping that you can see the power of groups at this point. And, even though this last example didn't really use groups, it was kind of nice to, go on this journey of discovery together, creating this character and whatnot. Or I don't know, pseudo character. It's not really like the most in-depth character ever, but it's just kind of a fun thing that we stumbled upon here. So at any rate, In the next section, what we're going to be doing is we're going to be looking at how we can create digital assets. Digital assets are prepackaged little tools like this. We create some, setup like this with a bunch of nodes, and we are liking what we've come up with, and we might want to use it again in the future. We can start building tools out of it to either use for ourselves or to give to other people or other artists so that it can make their lives easier as well. So catch you in the next section, and we'll do some digital asset work. Until then, stay tuned, and we'll talk to you later.